So welcome to East Academia. So my name is Brian, and today we are going to talk about some rules of limits. All right, so we'll talk about some rules of limits. So we'll just write here rules of limits. Okay, let me just do this so that I don't have to cover so much frame. So I will talk about rules of limits. So basically, these are some of the rules that will be guiding us when we are doing our works in limits. So the first one is the limit of a constant is the constant, okay? Limit of constant. So the limit of a constant is the constant itself, all right? So for example, if you're told limit as x approaches 5 over 10 is equals to, so you realize that on this side you don't even have x, so you can't substitute anything here, isn't it? Or we can assume that we have x raised to power 0 here, isn't it? Because x raised to power, ideally this is 10 times 1, isn't it? Because any number raised to power 0 is 1. So then that means it will be 10 times 5 raised to power 0, which then it's 1, it will remain 10, all right? So a the limit of a constant value is the constant itself, all right? Then number 2, we have what is known as the sum rule, all right? Sum rule. So I will write lim as x approaches c, okay, of and I have f of x plus g of x, isn't it, is equals to limit as x approaches c of f of x plus limit as x approaches c of g of x. All right, so these functions, you can, what it means is you can just sum the equations and then evaluate them at c, or you can even do them individually, isn't it? So if you want an example, we shall do an example at the end that is going to show you these limits. So for the difference or the subtraction, all right, is still the same thing, all right? So it is this one, but now you're just going to put a negative sign. So I can write plus or minus because this equation still maintains. So in this case, if this one is L, I'll add a minus here, so it will be L or minus M. And this one, the limit gives us M, it will be L plus or minus M, all right? I will give an example to demonstrate this later. And then we are going to the product rule over limits. So that is 4. So product rule, I'll just abbreviate PR of limits, okay? So what it means is that when you are multiplying, so we'll write limit as x approaches c, isn't it, of f of x multiplied by g of x. This is the same as taking limit as x approaches c of f of x and multiplying it by limit as x approaches c of g of x, isn't it, which is equals to L times M. Right. Yeah, so that is what it means. We shall give an example later. And then we have the quotient rule, QR of limit, isn't it? So this is division, okay, when you divide. So this, it means x, limit as x approaches c, f of x over g of x is equals to, same thing, is equals to a limit as x approaches c of f of x over limit as x approaches c of g of x is equals to L over M. And of course, you realize in division, you are not supposed to divide with 0. So this one holds provided M is not equal to what? Is not equal to 0. All right, so this unequal sign, then you cross means not equal to 0. So provided M is not equal to 0. And if M is 0, then that means that limit is going to be indeterminate, undefined, or in simpler terms, it's going to be an impossible limit. All right, so then we go to 6. So this is a multiplication by a constant. So multiplication by a constant. So what it means is if you have a constant value, so limit as x approaches c, isn't it, over k f of x, isn't it, is equals to the same. The constant can come outside, then multiplied by the value of the limit here, like that. You can even put brackets like that so that you don't confuse. Then this will be the same as k times l. Right. So then now for these rules of limits, I'm only going to give one example that will definitely cover almost every aspect of that we've discussed about in those rules of limits. So in this case, our example is to evaluate. Let's see. In this case, our example is to evaluate the following limit. So you're told to evaluate the following limit, and the limit itself is a limit as x approaches 3, and you are given x cubed plus 4x squared x minus 7 over x plus 1. So that is what you have. So if you use these rules, you realize here we have addition here, this one and this one. We have multiplication here, this function and this function. We have division, this upper function divided by this function. What else? We have limit over constant, which is here, 7. So this one basically just covers everything. So in this case, we can easily just do a substitution because we know the rules. All right, so this will be now 3 cubed plus 4 times 3 squared, isn't it? Then these ones are bracketed, and then we'll have 3 minus 7 over 3 plus 1. So as simple as that. We're going to have 9 plus, this one 9 plus 36, isn't it, into brackets. And then here I have minus 4 over 4, isn't it? That's the case. Is that the case? So 3 cubed is 27. This is supposed to be 27, not 9. 27, okay, plus 36, right, minus 4, divided by 4, then this can go. And we are remaining with minus 1. So 27 plus this one is going to be 63. So the answer will be minus 63. And I think I'm doing it in a very simplistic way. But if you realize, you can do it individually, all right? And you're still going to get the answer as it is. So in the next video, we are going to talk about techniques of evaluating limits. So thank you for watching this video and have a nice time. Thank you. Remember to subscribe to East Academia for more videos. Thank you.